Howdy, howdy, folks. Welcome to Psych 652 Lab, Module 5. Today we're going to be discussing categorical variables and how to handle them in R. So the first thing we're going to learn is we're going to learn how to factor variables in R. Then we're going to learn how to do a chi-square analysis in R on your factored variables. And then we're going to learn how to calculate odds ratios by hand and through the EpiTools package oddsratio.wald function. So let's go ahead and get started. Okay. So as usual, we're going to go ahead and open up RStudio. And we're going to go ahead and create that new project for us so that we can have a Module 5 lab project. Make sure it's saved to the correct subdirectory. And I'm going to go ahead and name this module underscore 05. I'm going to go ahead and create project. All right, looks like we got it loaded up. And we're going to go ahead and download our data set now. So the data set we'll be using is in your modules folder. Go down to scroll down to Module 5 Lab. And you'll be using the gss.csv. This is the general social survey. It's just a general questionnaire that they handed out to people. It gives things like class, degree, sex, marital status, what their race is, and so forth. And notice how a lot of these variables are actually character variables and are not actually numeric to a sense. So we're going to be actually today giving numeric values to these character variables because they have actual levels associated with them. Take, for example, male, female. It could be assigned as 1 and 2, 0, 1, either way. So we'll go ahead and do File, Save As, Browse, and go ahead and find out where that subdirectory for your Module 5 project was. And we'll go ahead and save it as GSS. We can go ahead and exit out. And we'll go ahead and confirm that it's saved within our project file. Yes, it did. We have our gss.csv available in our project file. So now we're going to go ahead and create a new R notebook, which is in the upper left there. Go ahead and delete all this unnecessary text. And I'm going to go ahead and load up some notes here real quick. All right. So we've gone ahead and created our R notebook. Let's go ahead and title our notebook. Today's notebook, I want to title Analysis of Categorical Variables. And per usual, I always like to make a table of contents. So remember this YAML header, you press Enter, Tab, colon, Enter, TOC, colon, space, yes. So we got our table of contents ready to go. And we're going to go and save the notebook too. And I'm just going to name it Module 5 Notebook. And save. All right. Looks like we're ready to go. So as usual, the first thing we're going to do is load our libraries up. Today we're going to be using two different packages. One of them you're going to have to install yourself. So we'll go ahead and insert a new R chunk. So first one, always, library, tidyverse. I think just about every time we're going to be using the tidyverse package in this class. So you'll just want to have that on hand, always ready to go. Next, we're going to install a package called EpiTools. So you use install.packages, and in quotations you type in EpiTools. And right under that, we'll go ahead and call it up as well through the library function. So we're prepared to use it right away. So assuming everything is correctly spelt, we'll go ahead and press play and learn. So first it's loading up our tidyverse package. Now it's installing the EpiTools package. There we go. And it loaded up our EpiTools package. And it looks like EpiTools was successfully installed, so we're good to go. All right. So the next thing we want to do is go ahead and read in our data. So do hashtag read in data. And we're going to be using that gss.csv file. So let's go ahead and put this up here a little bit more. So let's go ahead and name it as an object called GSS. Use your assignment operator. The function read underscore CSV, and in quotation marks it's gss.csv. Make sure it matches exactly what your data set is called. And we'll go ahead and press play. All right, looks like we got a new object called GSS with 149 observations and 11 variables. So the amount of variables we have in here is a little bit too much for me. I want to go ahead and reduce the number of variables to about let's say let's get it with 5 different variables. Let's say we want a new data set with only ID, sex, happy, zodiac, and party, actually. So the way that we're going to do that is we're going to go ahead and reduce the data set to just variables of interest. And it'll just make it a little bit easier for us later to have a smaller data set to work with. So we're going to go ahead and name this a new object called GSS underscore reduced. Use your assignment operator, and we're going to use the select function because we're selecting columns. So you select parentheses, you name your GSS data set, and we're going to be creating a new data set called GSS reduced, and we want the ID variable, comma, we want the sex variable, comma, we want the happy variable, comma, we want the zodiac variable, comma, and lastly we're going to take the party variable. So this should be a data set of 5 different variables when we load this up. Yep. So it's 149 observations of 5 different variables. Okay, so it's a little bit nicer to work with. So a little bit easier to handle these smaller data sets. Whenever I'm working with R, I usually try to make my data set as small as possible so that I kind of know exactly what I'm working with. So I always like to get the structure of the data set, and I think it's extremely important here because I'm actually going to be showing you how our structure is going to change once we learn how to factor our variables. So let's go ahead and get the structure of the data set. All right, let's go ahead and insert a new R chunk. So to get the structure, the function is just str, and we're going to get the structure of the GSS reduced data set. So let's go ahead and run that. So look, some things you'll notice that we have a table with 5 variables and 149 observations. We have our ID variable, which is numeric, but these other variables are character. And really, we're going to actually go ahead and change those from a character variable to a numeric variable. And all that is saying is that we're going to give numeric values to these character texts so that we can do other specific functions with it. So let's go ahead and just write, notice how 4 of our variables are character variables. And we can go ahead and just write CHR there, just because it's so we know what we're talking about. And we'll go ahead and type, these will give us problems later if we don't do something about it now. Okay, and I'm going to go ahead and just get a summary of the data set as well. So let's go ahead and get a summary. Get summary of data set. And go ahead and create a new return. And we're going to see exactly why character variables are not ideal to work with. So GSS underscore reduced. So these are not ideal to work with specifically because when we get a summary, yeah, ID gave us some mathematical functions with it. We got the min and the max and the mean, but we don't even care about the mean of the ID variable. But our variables sex, happy, zodiac, and party, well, really, it's not giving us any information other than the fact that it's telling us that it's a character variable. We're going to go ahead and change that using the mutate function now. So we're going to be doing something called factor the variables via mutate. So mutate has a lot of different capabilities beyond that what we learned last week, and we're going to keep building on to what these other capabilities of the mutate function is. So let's go and create a new R chunk. And actually, before we write anything in our chunk, I just want us to kind of write a note. Just say factoring variables provides a numeric value to a character variable. And you'll see what it's going to do. We're going to call it the structure of the data set again and see how it changes after we do this. So let's go ahead. What we're going to do is we're actually going to overwrite our GSS reduced data set. And we're going to be actually overwriting variables overall. So we use our mutate function. First thing we do is call the GSS underscore reduced data set, comma, and just a little note about R. Every time you enter in a comma, you can go to the next line and it'll still read the line of code. So I'm going to press enter because I think it keeps me a little bit more organized. So what we're going to do is we're going to be overwriting all 4 of our character variables up here. We're going to be overwriting sex, we're going to be overwriting happy, zodiac, and party as well, and converting them into factor variables, or more or less we call it coercing them to factor variables. So we're going to write sex equals, and we use a function called as.factor. We put the sex variable in there. So what's going to happen here is it's going to mutate, call our GSS reduced data set, overwrite the variable sex, but overwrite it and turn sex into a factored variable. And we're going to go ahead and do that for the rest of our variables as well. And I don't know if this is clear to everyone, but in the mutate function, you can do multiple mutations within one mutate command. If you want to and you don't feel comfortable with that, you can have 4 different mutate functions going, but I like to keep it all in one mutate function. I think it keeps me more organized. So we're going to also do this to happy. So happy equals as.factor happy. Oops, if I can do it right. Happy, comma. I'm going to go ahead and do that. And then we're going to do zodiac equals as.factor zodiac, comma, enter. And then party equals as.factor party. And if we did this correctly, we should have a data set that actually looks pretty similar to what we had before. So it should have 149 observations of 5 variables because we overwrote all the variables that we mutated. So go ahead and press play. All right. And it looks like nothing really happened. So really your data set, again, it's kind of similar to some other capabilities like the group by function. Nothing looks different here. But when we run the structure of our data set again, it's going to look different. So let's go ahead and get the structure of the data set again. So we'll go ahead and create a new R chunk. And we're going to do str and then GSS reduced. Now when we go ahead and get the structure of the data set, it looks a lot different than what we had before. Before, if we go back, scroll back up, these were all read as character variables. Now we have factor variables with different levels associated with them. As you can see, we have a factor of 2 levels for sex. Happy is factor variable. So really, this did do something. Even though it doesn't look any different in your data set, we have converted or coerced these character variables to factor. So R said, okay, you want these to be read as something with a numeric value. Now, let's go ahead and get the summary of the data set again. Now we're actually going to have some very interesting output from our summary function. So go ahead and do summary GSS underscore reduced. Let's see what happens now. Now, as we can compare this to our previous summary function where it just said, hey, this is a character variable, I don't know what to do with it. Now it's saying, okay, sex has 2 different levels. One is female, one is male. And we go ahead and give you a count of each of these. So we have 91 females and 58 males. So it's a lot more informative. Now you'll notice that zodiac, it goes Virgo, Capricorn, Scorpio, Cancer, Aquarius, and then other. That's because the summary function deprecates anything that has more than 6 levels on it. But we can go ahead and change that too. So if we change this and add an argument called max sum equals, we're going to go ahead and change it to 12 because there's 12 zodiac signs in total, one for every single month pretty much. So if we go ahead and do max sum equals 12 and run this again, it's going to give us every single thing. You can set that max sum to 100. If you have more than 12 levels of a variable, you can just change that max sum so you can see how it works, what the frequency of all of them is. But see, even though nothing changed in our actual data set, it is a completely different data set now because we factor our variables. And it's important for us to factor their variables in this lesson because when we're running chi-square analysis, we're going to be creating tables. It looks a lot nicer and it'll give us more functionalities with our variables. So if you have a data set that ever comes to you and it's all in this character format, you're going to be running into a lot of trouble to start with, but factoring can go ahead and save you a lot of time and change a lot of things about your data set so that you can actually do mathematical functions on it. Okay, so we've kind of gone through the logistics of R and factoring variables. Now, because Kevin taught you about chi-square analysis in lecture, I'm going to go ahead and teach you how to do chi-square analysis via R. So Kevin kind of taught you kind of the mathematical basis of doing chi-square analysis. I'm going to teach you how to run this all in R. So let's go ahead and create a new header in our notebook called chi-square analyses. And we're going to go ahead and start another level. We're going to go ahead and do this in steps because I want to show you how to do this in steps. Now, I'll tell you, if you've run chi-square analysis in the past, you're probably going to notice that I'm going to be doing it a little bit differently. I'm trying to keep things in that kind of tidyverse area where we're not using the $ operators to dig into data sets. But just bear with me. It's going to help us out also when we do it this way so that we can obtain odds ratios later too. So we're first going to be creating a table and then getting a chi-square analysis from that table. So if you've done chi-square analysis, please just humor me and do it my way so that we can go ahead and you'll, like I said, it'll help you to get odds ratios later. So first thing we're going to do is we're going to say step 1. We're going to create a table of your variables. And I'm going to go ahead and write some notes. So below, we will be creating a table object of the variables sex and happy from the GSS reduced dataset. And then I'm going to say we will then view the object. Okay, so those are just some notes for us so that we can remember what we did later. And I'm going to go ahead and create a new R chunk. Okay, so the first thing we want to do, so we're going to be creating a table of an object. And essentially what that's going to do is just create it so that it bases your factors into columns and rows and sums them up, it counts all the numbers into one. So the first thing we're going to do is actually start by selecting only the variables of interest. So for our first chi-square analysis, we're going to be getting the chi-square analysis of the relationship between our sex variable and our happy variable. So let's go ahead, and what I like to do is just name my variables in my objects. I'm going to name my new object called sex underscore happy. And we're going to use an assignment operator, and we're just going to select the sex and happy variables. So first we do our data set, GSS underscore reduced, comma, sex, comma, happy. So if we go ahead and run that line of code, go ahead and run selected lines, we have a new object on the right here called sex underscore happy, which is just the sex variable and the happy factored variables. Then we're going to create another new object called sex happy table and use our assignment operator, and we're going to use a function called table, and we're going to table this sex underscore happy. And what it's going to do is really just create a frequency table for us. So we just do sex happy, and what's going to happen is it's going to take this sex happy data set and count it up and sum everything by category. So let's go ahead and do it, sex underscore happy. So you'll notice it created a value, not a new data set. So this tabling function does something different. It's making a matrix variable so that we can do other mathematical calculations to it later. But we go ahead and we just view sex underscore happy table. If you go ahead and just view it, so you can go ahead and just view it by typing in the name of the object and it'll display in your output console. So go ahead and do that. All right, so we have a table here that has sex in the rows, so female and male, and happy in the columns, happy and unhappy. And it gives us a frequency count of all of our variables. Okay, so now we're going to use this table to run a chi-square analysis. So let's go ahead and do step 2, hashtag step 2. And what we're going to say here is run chi square.test on the new table object. So we have that new table object, which is really just a matrix of our variables. And we're going to go ahead and create a new R chunk. And we're going to run the function called CHISQ.test. There's a lot of different ways you can run this function. Again, if you ran it in the past, like I said, it's probably going to look a little bit different than how I do it. But I'm going to go ahead and just type in my table. So that table that we have up here we're going to run a chi-square analysis. So it's chi-square sex happy table. And if we go ahead and run the play button here, there we go. It doesn't have much output, but essentially what we're seeing is this chi-square analysis that's been run on it. It says it calls up our data set, so it says this is for the sex happy table. And what it does is it gives a chi-square value. So our chi-square value is 8.4605. We had 1 degrees of freedom. And Kevin taught you how to calculate degrees of freedom in the lecture. And we have a p-value of 0.003. So that's less than 0.05. So what we're saying is that there is not independence within our happy table here, our sex happy table here. So essentially, we're saying that somehow there's a difference between the numbers within this table. So the next step we're going to do, now that we've ran our, I'm going to go ahead and put this as a second level header actually. And yep, second level header. The next thing we're going to do is we're actually going to calculate an effect size for our chi-square test. So we're going to do step 2.1. And in this, we're only doing this because we found a significant effect. Step 2.1. If significant, calculate the contingency coefficient effect size. Okay, so we're going to create a new R chunk. And we're going to go ahead and calculate the contingency coefficient effect size. And I'm going to go ahead and just copy and paste a note here rather than typing it out. So the contingency coefficient effect size is something that you learned about in Kevin's lecture. And what it is it's getting the effect size of our chi-square analysis and saying how strong of an effect is this. And the calculation, and we're actually just going to be calculating it by hand, is the square root of your chi-squared value divided by your chi-squared value plus your n. And our n we can find out from our observations. So we have 149 observations. So we say, okay, let's go ahead. And then the function for getting the square root in R is sqrt. The square root of our chi-square value, which is 8.4605. divided by, and we're going to have to put these in parentheses, our chi-square value, which is 8.4605, plus our n. Our n is 149. 149. And if we go ahead and run that, what it's going to do is just run just like a normal calculator. It's going to take the square root of 8.4605 divided by 8.4605 plus 149. Go ahead and run that. And we get a value of 0.2317993. So our effect size for our chi-square test is 0.2317993. So that's a moderate effect size from what we're seeing, but that's essentially all you need to do there is calculate your effect size. If it wasn't significant, we wouldn't calculate the effect size. Okay, so let's go ahead and do another chi-square analysis, just so we get a little bit more comfortable with it. Another chi-square analysis. So we'll do, okay, go ahead and do it in steps. So we're going to go ahead and do step 1. Step 1, create a table of your variables. So this time, I'm interested in, let's go ahead and go to our GSS reduce party. I'm going to see if there's a relationship between sex and party and see if that violates any kind of scrolls of independence here. So go ahead and do chi-square of sex and party. So the first thing we need to do is table our variables. So first, we're going to create our new object. I'm going to name it sex underscore party. This is our assignment operator. I'm going to select our variables of interest. So we're going to select it from the GSS reduced data set, comma, we want the variables of sex and party. So if we run that line of code, we have a new data set called with only sex and party. Then we're going to create a new object called sex underscore party underscore table. And we're going to use that table function again to create a matrix of just these variables. So sex underscore party. So we go ahead and run that line of code. There we go. Go ahead and run that line of code. We have a new value called sex party table, and we can go ahead and view that as well. Sex underscore party underscore table. And I'm just going to go ahead and run the whole thing again. And there we go. Now we have 3 columns and 2 rows, essentially. So now we're going to run a chi-square test of independence here too. So go hashtag step 2 run chi-square dot test on the new table object. And we'll go ahead and create a new R chunk. And from here, we use our chi-square.test function on our new table, which is sex underscore party table. And if we go ahead and press play, so we'll see, okay, we got a Pearson's chi-square test. Data is sex party table. Our chi-square value is 1.1742, so lower than before. Our degrees of freedom are now 2, and we have a p-value of 0.5559, which isn't significant. So in reality, there is all these, they seem to be close to each other. There's no, they're independent of each other completely. So it doesn't really matter too much, male and female separated by party. There's no difference between male and female in the ways that they choose their party, essentially. So now we really don't have to go to step 2.1 at all. There's no point in calculating a contingency coefficient effect size because we didn't find a significant p-value from our chi-square test. So that's how you calculate a chi-square test in R. Now, again, I know some people have probably calculated a chi-square test in the past and it's a little bit different, but that way it fits with the tidyverse approach, and we're going to be utilizing it to get our odds ratios later as well. So let's go ahead and actually, let's start going for our odds ratios. So let's go ahead and create a new header in our notebook called get odds ratios of our sex, what was it, variables that we had before? Sex happy table, of sex happy table. But we're going to do another second level. We're going to first calculate it by hand. So we're going to do a third level header now. We're going to say we're going to get the OR, so the odds ratio of males being unhappy as compared to females. And it's very specific that I order in that way because the way that we're going to be calculating it is going to be essential. So I'm just going to go ahead and create, I'm going to create another third level header and say calculate, or actually let's just go ahead and get our table back again. Get our table. So let's go ahead and do it because we're going to need this table to calculate by hand. So we're going to go ahead and just call back the sex happy table. Go ahead and run that. And we see our table again. So what we're trying to do is from this is get the odds ratio of males being unhappy as compared to females. So it's going to be the difference between these values compared to these values across sex variable. So let's go ahead and calculate the odds ratio by hand. Okay, do that. And then we're going to go ahead and create a new section. Oops, I pressed the wrong thing. Go ahead and create our new R chunk. All right, so to do this, in Kevin's lecture, you had the calculations of how to calculate odds ratio. So we're essentially just going to be doing it by hand. And the way that I like to do it is go ahead and first calculate the odds of males being happy. We go ahead and I'm going to create a new object called males underscore happy using an assignment operator. And I'm just going to go ahead and see what are the odds of males being happy. So calculate the odds of that, you do 37 divided by 78. So the odds of males being happy as compared to females being happy. So that's 37 divided by 78. That's the odds that males will be happy. So if I run that line of code, we're going to get something that appears as a value to the right here. So go ahead and run selected lines. So males being happy, so males are 0.47 times as likely to be happy as compared to females. So in reality, and speaking of odds, that means they're less likely to be happy. Because remember, odds go from 0 to infinity. And anything above 1 is considered more likely. Anything below 1 is considered less likely. So males are less likely to be happy as compared to females in the odds here. Then we can go ahead and calculate the odds for males being unhappy. So we go ahead and we calculate the odds of males being unhappy. So we have so we go ahead and create a new object called males underscore unhappy. Go ahead and create an assignment operator. And our function, and what we'll do is compare the males being unhappy to females being unhappy. So that's going to be 21 divided by 13. So go ahead and run that line of code, and we'll get a value in our values section. So it looks like males are more likely to be unhappy as compared to females. There are in fact 1.615 times to be unhappy as compared to females here. Then we can get the odds ratio. Get the odds ratio. Now we're actually going to compare how unhappy males are being unhappy as compared to females being happy. So we do the males unhappy divided by males being happy. And we can go ahead, and I'm going to go ahead and just display it in our output as well. So if you just type it in, so first we're going to run this line of code. So run it. So as you can see, our OR shows up over here. And then we go ahead and run our OR. So what happened is we got the odds ratios of males being unhappy as compared to females. So really, males are 3.41 times as likely to be happy as compared to females. So we can go ahead and write that. So males are 3.405 times as likely to be unhappy as compared to females. Next, now that we've obtained our odds ratios by hand, I'm going to prove that this is correct by essentially running it a different way. Now we're going to use the EpiTools package to calculate the odds ratio so that we don't have to go through these mathematical functions every single time. But it is important to know how to calculate them by hand, which is exactly why I did that. So let's go ahead and hashtag, then calculate the OR, odds ratio, via odds ratio dot wald from the EpiTools package. Just so you remember what the package is from is, go ahead and insert a new R chunk, and we're going to use a function called odds ratio dot wald. There's a lot of different types of odds ratios you can calculate. We're going to use the most basic one, which is the wald odds ratio. And all you do is you plug in that sex underscore happy underscore table that we had up here, and it's going to go ahead and calculate the odds ratio for whatever is on the bottom right here. So for males being unhappy, it's going to go ahead and calculate the odds ratio for us. So we go ahead and press play on that. It provides a lot of output for us, but essentially it provides our table for us. It gives us it also entails the totals as well, so that if we wanted to, we can calculate risk ratios if we wanted to as well, but we're only calculating odds ratios. So you'll notice it's giving us the odds ratio here, and it says, okay, females are 1, because that's the comparison category. So it's saying females are just as likely to be unhappy as females are likely to be unhappy. However, it says how likely are males to be unhappy? It says, as compared to female, males are 3.405 times as likely to be unhappy as compared to our females. And it also gives us some more information like the 95% confidence intervals, which Kevin taught you how to calculate by hand as well, and some other things as well, saying, is this significant as well? It says, are males significantly more likely to be unhappy as compared to females? So as you can see, males are much more likely to be unhappy as compared to females. In fact, they're 3 times as likely to be unhappy as compared to females. And again, that matches the exact value that we obtained up here when we calculated it by hand. So that really ends off the lecture for today. So we went through a lot of different steps today, right? So just to kind of sum it up, we used the EpiTools package. I'm going to go ahead and comment that out. We downloaded the Tidyverse and EpiTools package. We read in our data. We got the structure of our data up here and noticed that those were character variables and said we don't really like to work with character variables when we're doing functions. So we converted them all to factor variables and got this structure again and noticed that these character variables changed. Then we got a summary of all of our variables. Then we ran through the steps to get a chi-square analysis. And then we calculated our contingency effect size. We ran through and did another chi-square analysis that we didn't find significance on, so there's no point in doing the effect size. And then we created our table. We calculated an odds ratio by hand, and then we used the odds ratio.wald function to calculate the odds ratio as well. So I'm going to go ahead and save my notebook. Go ahead and preview it as well. And voila, we've got a really nice notebook here that has a lot of information for us that we can use for later. We can go ahead and first calculate by hand and so forth. Okay, so let me go ahead and check on my time now. Okay, so we're only at 36 minutes. So what I'm going to do is just go ahead and show you how to get to the assignment now. So you go ahead and go to our, we'll go back to home. So we go to our modules page on Canvas. Scroll down to Module 5 Lab. And what we're going to do is we're going to go ahead and download the Module 5 Lab Activity.pdf. Okay. And I'm going to go ahead and file Save As into the Module 5 folder that I have created. Actually, desktop, Success 52, Module 5. Delete that. I'll press Save. All right, and for this lab activity, you're going to be using a data set. I can't remember what the data set was. The sleep_cat.csv file. So what this is a data set that I kind of manipulated so that has all character variables, and you're going to actually be working on this in order to convert these character variables into factors. So let's go ahead and download this CSV file. Do File, Save As, Browse, and go ahead and go to our desktop, Success 52, Module 5. Okay, and then we have our data set as well. All right, and then I also have on here, I also have a description of the data set as well. So go ahead and run through the Module 5 lab activity. Be sure and contact me if you have any questions at all, and turn in your Module 5 lab activity when you're done. Thank you so much.